Welcome to Physics Concepts Lecture 19. Today, we will explore the fascinating world of waves. Waves are disturbances that transfer energy from one place to another without transferring matter. Let's dive in and understand the different types and properties of waves. A sine wave is a smooth, periodic oscillation. It is characterized by its amplitude, wavelength, and frequency. For example, electrons in a transmitting antenna vibrate 940,000 times each second, producing 940 kHz radio waves. This waveform can be visualized using a moving conveyor belt and a pendulum swinging at right angles above it. Waves have several key properties, including frequency, wavelength, and speed. Frequency is the number of vibrations per second, measured in hertz. The period is the time it takes to complete one vibration. Wave speed is the speed at which waves pass a given point, calculated as frequency multiplied by wavelength. Waves can be classified into transverse and longitudinal types. Transverse waves vibrate perpendicular to the direction of motion, like light waves. Longitudinal waves vibrate parallel to the direction of motion, like sound waves. Both types transfer energy from one place to another. Waves can have different frequencies, resulting in various patterns. A stationary wave pattern forms when two sets of identical waves pass through a medium in opposite directions. The frequency of these waves determines the number of nodes and antinodes in the pattern. Interference occurs when two sets of waves overlap, producing reinforcement in some places and cancellation in others. Constructive interference results in a larger amplitude, while destructive interference reduces the amplitude. This phenomenon can be observed in various wave patterns. The Doppler effect is the change in frequency of a wave in relation to an observer moving relative to the wave source. When a source moves toward you, the pitch increases. When it moves away, the pitch decreases. This effect is commonly experienced with sound waves. Bow waves are V-shaped disturbances created by an object moving across a liquid surface at a speed greater than the wave speed. These waves form concentric circles that spread out from the point of disturbance, illustrating the relationship between speed and wave formation. A sonic boom is a shock wave created by an object moving at supersonic speed through a fluid. The high-pressure cone at the bow of the aircraft and the low-pressure cone at the tail combine to produce a loud sound. This phenomenon is a result of the object exceeding the speed of sound. Let's summarize some key terms related to waves. A sine curve is a waveform traced by simple harmonic motion. Amplitude is the maximum displacement from the equilibrium position. Wavelength is the distance between successive crests or troughs. These terms are fundamental to understanding wave behavior. Frequency is the number of vibrations per unit time, measured in hertz. The period is the time for one complete vibration. Wave speed is the speed at which waves pass a point, calculated as wavelength multiplied by frequency. These properties are essential for analyzing wave motion. Transverse waves vibrate perpendicular to the direction of travel, while longitudinal waves vibrate parallel. Interference patterns form when different sets of waves overlap. Understanding these types and their properties helps us analyze various wave phenomena in nature. Standing waves form when identical waves pass through a medium in opposite directions. The Doppler effect describes frequency shifts due to motion. Bow waves are disturbances from objects moving faster than wave speed. Shock waves and sonic booms result from supersonic speeds. These phenomena illustrate the diverse behaviors of waves. Thank you for watching. Please like, share, and subscribe to this channel. Add a comment below the video to share your thoughts and questions. What did you learn from the video? What topic would you like to explore further? This presentation contains copyrighted material used under the Fair Use Doctrine for educational purposes. All rights belong to their respective copyright holders. Links to relevant resources are provided in the video description.